You've never been to heaven, have you?
Assalamualaikum warahmatullahi wabarakatuh. Hi everyone.
Hello everyone.
Hello everyone.
Back again with Heaven Group. So in this video, we are going to explain about input-output of a matrix. But before we start, let us start with introducing ourselves. My name is Andi Putri Ahira.
My name is Dayana Anissa Putri.
My name is Audriana Septiani.
My name is Denzel Sudjono
From Heaven Group.
From Heaven Group.
from the Heaven Group.
From Heaven Group International Management Class, Faculty of Economics and Business Untan.
So in this video, I'm in charge of explaining transaction table.
In this time, I will explain about the exercise of table transaction and matrix relative.
And in here, I'm in charge to explain about the practice questions.
Transaction table is one way to organize production data in a sectoral way. The relationship of transactions between sectors shows that one sector requires inputs or factors of production in the form of raw materials, which are products or output of other sector. Transaction table expressed in units of money. The transaction table also shows how much the output of a sector is, how much part of the output is sold to other production sectors as a raw materials, how much is consumed by non-production sectors such as household sectors. The table of transactions or the input-output of the economy consisting n sectors in general can be expressed as where xn1, xn2, xn3, and so on is the production sector, and the fn such as f1, f2, f3 is the final demand, and the xn, which is x1, x2, x3, and the last column is total output. Also, the v1, v2, v3, and so on is the added value. For each of the sectors, applies the following system of equation: x11, x12, x13, and x1 so on, plus 2f1 equals to x1. We can get the conclusion by this equation is that we get total output from computing or calculating all of the production sectors plus the final demand. It's equals to total output. So we can get the total output from all of the sectors and the final demand. This is the example of transaction table. The following is the example of a transaction table for an economy with three sectors, namely the agricultural sectors, the industrial sector, and the service sector. So there are three sectors, which is agricultural, industrial, and the service sectors. Now, remember the equation to get the output total, which is x11 plus x12 plus x13, and so on, plus f1 equals to x1. So to get the output total, for example, to get 72, we have to compute all the sectors, including the final demand, to get the output, the total output. So 20 plus 19 plus 3 plus 30 equals to 72. So that's how we got the total output. If you read down or follow each column, we will get the total output value of each sector, which is broken down according to the number of production factors or inputs used for it. So for the first column, the total output value of the agricultural sector was 72, which I already showed you. How do we get the 72? That much value is produced using production factors or inputs, as many as 20 from the agricultural sectors, as many as 5 come from the industrial sector, and as many as 4 are from the services sectors. And the remaining 43 are the added value which generated by the sector. So you might asking, how do we get the 43 as the added value? So to get the added value, we have to compute all the sectors, and then after that, minus 2 the total output, which is 72. So 20 plus 5 plus 4 minus 272 is 43. So that's how we get the added value for 43. For the second column, the total production output of the industrial sector is worth 232, which we get from all the sectors plus the final demand, which equals to 232. Of that number, 19 were inputs from the agricultural sectors, 81 are inputs from the sector itself, namely the industrial sectors, and 37 are inputs from the service sectors, and the remaining 95 are the added value generated from the production process in the industrial sector. So that's how you get the added value. I already show you how do we get the added value, which is we compute all the sector and minus the total output, which is 232. So the result is 95 as the added value. Note that when we sum columns, the final request or the final demand for all sectors will get the same number as the sum of added value. So 243 for a final demand and 243 for added value, which will get the same number for all sectors. This should be the case because the value of GDP can be obtained in two ways, as GDP equals to the sum of added value of every sectors, and GDP equals to sum of the final demand or final result of every sector equals to C plus I plus G plus X minus 2M.
Today, let's take a look at everyone's favorite metric application problem, Leontief input-output models. You might know them simply as technology metrics problem, but actually, the technology metrics is only one part of the problem. The Leontief models is a model for the economics of a whole country or region. In the model, there are n industries producing n different products such that the input equals the output, or in other words, consumption equals production. The first one is open models. Some production consumed internally by industries, rest consumed by external bodies. For the problem, find production level if external demand is given. The second one is closed models. Entire production consumed by industries. For the problem, find relative price of each product. This is for the examples of open models. We are being asked to determine the following: how much of the production of each of the three industries F, C, and T is required to produce 1 unit of F. In the same way, how much of the production of each of the three industries F, C, and T is required to produce 1 unit of C. And finally, how much of the production of each of three industries F, C, and T is required to produce 1 unit of T. Since we are looking for the proportion, we need to divide the production of each industry by the total production for each industry. So we analyze it and we obtain the following matrix. After that, use this formula to find the matrix A. And this is the examples of closed models. We assume that in a village there is a farmer, carpenter, and a tailor who provide the three essential goods: food, shelter, and clothing. Suppose the farmer himself consumes 50% of the food he produces and gives 50% to the carpenter and 20% to the tailor. 30% of the carpenter's production is consumed by himself, 50% by the farmer, and 30% by the carpenter. 50% of the tailor's production is used by himself, 30% by the farmer, and 20% by the tailor. Write the matrix that describes these closed models. For the solution, first we can make the table according to the previous information in the question. After that, we can find or we can write the matrix. This matrix is called the input-output matrix. It is important that we read the matrix correctly. For the example, the entry A23, it means the entry in row 2 and column 3 represent the following. 20% of the tailor's production is used by the carpenter, and 50% of the tailor's production is used by the tailor.
How to read the table? The table is read by horizontally. If the table is read by horizontally, we need to read the table from the left side to the right side. The first row states that the total of the output of the fishery sector is 139 billion rupiah. From 139 billion rupiah, 20 billion rupiah used by the fishery sector itself, and 45 billion rupiah used by the industry sector, 18 billion rupiah used by the service sector, and 5 billion rupiah consumed by the other non-productive sector. Next, for the second row, the total output of the industry sector is 154 billion rupiah. From the total of output, fishery sector used 34 billion rupiah, 70 million rupiah for industry itself, 32 billion rupiah for the service, and 18 billion rupiah used by other non-productive sectors. Next, for the second question, suppose that a simple economy consists of three sectors. Agriculture is A, manufacturing is M, and transportation is T. Economists have determined that to produce 1 unit of A requires 1 per 18 units of A, 1 per 9 units of M, and 1 per 9 units of T, while production of 1 unit of M requires 3 per 16 units of A, 1 per 4 units of M, and 3 per 16 units of T, and production 1 of unit of T requires 1 per 15 units of A, 1 per 3 units of M, and 1 per 6 units of T. Calculate the Leontief matrix. From the question above, we can know that to produce 1 unit of A, we need to use 1 per 18 units of A, 1 per 9 units of M, and 1 per 9 units of T. Next, to produce unit of M, we spend 3 per 16 units of A, 1 per 4 units of M, and 3 per 16 units of T. Last, to produce unit of T, we require 1 per 15 unit of A, 1 per 3 units of M, and 1 per 16 units of T. Next, we input all these numbers to the matrix form to find input coefficient matrix. So the input coefficient matrix is matrix 1 per 18, 3 per 16, 1 per 15, next 1 per 9, 1 per 4, 1 per 3, and the last column is 1 per 9, 3 per 16, and 1 per 6 matrix. So the matrix Leontief is I minus A. I minus A, so it is matrix 1, 0, 0, 0, 1, 0, and the last column is 0, 0, 1 minus matrix 1 per 18, 3 per 16, 1 per 15, the next row, 1 per 9, 1 per 4, 1 per 3, and the last is 1 per 9, 3 per 16, and 1 per 6 matrix. So the result of the matrix Leontief is matrix 17 per 18 minus 1 per 9 minus 1 per 9 minus 3 per 16, 3 per 4 minus 3 per 16, and the last is minus 1 per 15 minus 1 per 3 and 5 per 6 matrix.
Three sectors with consumption matrix M, which is 0.1, 0.15, 0.12, 0.20, 0.3, 0.25, 0.4, 0.2, and an external demand of D equals to 100, 200, 300. Find the total amount that must be produced and the internal demand. So we can calculate with the formula P equals to the matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 minus 0.1, 0.15, 0.12, 0.20, 0.3, 0.25, 0.4, 0.2 to the power of negative 1 and times with the external demand, which is 100, 200, 300. And we can find that the total amount that must be produced is equals to 281.3, 464.86, 695.34. And so the production of these three sectors should be set at these values. Most of the production is for internal rather than external demand, because external demand is only 100, 200, and 300. Then the internal demand can be found by 281.3, 464.86, 695.34 minus 100, 200, and 300, which is equals to 181.3, 264.86, 395.34. So the total amount that must be produced is 281.3, 464.86, and 695.34. And the internal demand is 181.3, 264.86, 395.34. Next is three sectors with consumption matrix M, which is 0.01, 0.002, 0.04, 0.02, 0.004, 0, 0, 0.01, and 0.02. And an external demand of D equals to 100, 200, and 300. Find the total amount that must be produced. As usual, we are going to use the formula P equals to the matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 minus the consumption matrix, which is 0.01, 0.002, 0.04, 0.02, 0.004, 0, 0, 0.01, and 0.02 to the power of negative 1. And we multiply it with the external demand of 100, 200, and 300. And we get the matrix of 113.873, 203.09, 308.195. And so the production of these three sectors should be set at these values. Most of the production goes directly to the external demand. So the total amount that must be produced is 113.873, 203.09, and 308.195. If a table transaction is the following: agriculture, industry service, total value, total output as the column, and as the row, agriculture, industry service, final demand, and total output. You can see the table in the slides, and the question is to find what is the value of output in the agricultural sector used by the input of its own sector, and B, what is the value of total output in the service sector, and C, what is the value of the service sector that is allocated for the input purchased from the industry sector, and D, what is the value of country A's gross domestic product, GDP. The answers are A, the value of output in the agriculture sector used by the input of its own is 11 million rupiah, which we can see from the table. And B, we can also get the value from the table, which is the value of the total output in the service section is 185 million rupiah. And for C, the value of the service sector that is allocated for the input purchase from the industry sector is 89 million rupiah, which we can get also from the table. And for D, the value of country A's GDP is equal to the added value of the final demand, which is equal to 222 million rupiah.